Alright, let's take a look at section 8.5. This is called Angles of Elevation and Depression. This is actually one of those lessons where it's actually practical. Okay, I know a lot of times you don't think they're practical, but this one definitely, it takes this the trig functions that we've been learning and it puts it into practice, I guess. So let's just talk about what an angle of elevation depression is. It's really not that difficult. Let's just draw a horizontal line right here. And, oops, let's not draw it like that. Let's draw it like this. I was actually drawing it in black, but black on black doesn't show up. So let's try this. There we go. Alright. This pretend this is like the ground level. Okay, look, don't make fun of me for my drawing, but this is I guess this is kind of something that you could use this for. So pretend, I don't know, let's just draw a vertical right here. Pretend this is some kind of the top of the building or something, and what you're doing is you're looking down. You're looking down at something down here. I don't think I was going to draw like a tree and a person and this kind of stuff, but let's not do that. Let's just make it a little bit easier to see. So let's say that you are up top here and you're looking at a point down here. Whatever. Sometimes these problems say you're on top of a cliff, you're looking at a sailboat down here, and this is the water and that kind of stuff. We'll do as an example or two, and I actually copied the pictures, or I scanned the pictures from the book, so it's the same exact pictures that are in the book. But just for the sake of just teaching you what these angles are, let's just go ahead and do this. So what I want to do is take a look at a line of sight. I want to start from this point right here where we are, and I want to look down to here. So let's draw just a line that goes straight. Oops, ran out of room. Let's try that one more time. Let's get rid of that. Let's try it again. Okay, so if I draw a line of sight from here to here, it would look like that. Now, obviously, we have a right triangle. But what did I just draw? I drew either an angle of elevation or an angle of depression. Let's talk about this. Watch this. Let's change this color of that line to this pink color. Okay, so this is our line of sight. Now, is this the angle of? So we're starting here. This is where we are. Okay, and we're looking down to this right here. Is this the angle that we're talking about? Well, let me do this. Let me just draw a horizontal line from right here. You'll see what I'm talking about in a second. A little scattered right now, but alright. So look at that horizontal line. That would be from the top of this, whatever it is, this mountain, this building, the top of a tree, whatever you want to talk about. You're up here. This would be looking horizontally. Now notice, it's parallel to the ground, let's say, or the ocean. Pretend we're on top of a mountain, you know, near the ocean, and this was a boat sailing along, and you wanted to look. You're viewing from here, and you're viewing way straight down to this. Well, the angle of, watch this, from the horizontal to that line of sight. So if I'm standing on top of this hill or this mountain or whatever it is, this top of this building or top of a tree, I take from the horizontal and I'm looking down to this line of sight. Okay, so if I was to look straight across horizontally, this would be the horizontal line. But my line of sight is straight down to this. So look at this angle that I've formed right here. This angle right here, since it's going down like this, we call this the angle of depression. So let's just write that out. Okay, we would call that the angle of depression, because depression means you're going down. Right? Alright, so this is the angle of depression. Well, conversely, watch this. What if you're down the bottom and you're looking up? Well, where's the horizontal here? Well, the horizontal is along the ground or along the water or whatever you're talking about. So what is that angle? That angle is up like this. Now, this is not the angle of depression, because what are we doing? We're going from the horizontal up. This goes from the horizontal down, so down, depression. This is the from the horizontal up, so this is elevation. So this angle right here is the angle of elevation. Now you're probably already seeing something right away, I believe. I hope you are. Look at this. If this is horizontal and this is horizontal, they're both parallel to each other. So watch. This angle of depression is the exact same angle as this angle of elevation. So if I was standing up here and I was looking straight across, and then I said, oh, wait a minute, down here is a boat I'm looking at. So where does my eye go? My eye goes down to here to this line of sight, and it looks at this boat down here. That would be the angle of depression. But what does it form, though? It forms this right triangle, and so this angle of depression is the exact same angle as this angle of elevation. For instance, if I'm looking out here, the horizontal's here, and I'm pointing down here, they actually make devices that measure this angle of sight, I guess. Okay, let's just pretend, I don't know, I'm just saying, let's say it's 10 degrees. We're just making this up. So this angle of depression is 10 degrees. Well, what would the angle of elevation be? If I was down here at this boat, we'll say, and I was looking up to the top of this hill, this top of this mountain, the angle of elevation is going to be the same exact angle as the angle of depression. So if this is 10 degrees, then this angle right here would also be 10 degrees. Okay? So hopefully that makes a little bit of sense, that the angle of depression is equal to the angle of elevation. Now how does that help us? Well, it helps us a lot, because now I know an angle inside my triangle, and if this is horizontal and this is vertical, that means that's a right angle right there. And check it out. I've got a right triangle, I know an angle, and what they're going to do in some of these examples, they're going to give you one of the sides. They'll either give you the vertical, they'll give you this horizontal, or they'll give you the line of sight. And then you have to find one of the other things. And so that's the kind of thing that you're going to do for this angle of depression and angle of elevation. So really the only teaching involved here is just understanding, taking a look at the word problem, taking a look at the picture. Sometimes they provide a picture, sometimes they don't. Sometimes you have to provide the picture. They'll just give it to you in words, and you have to take that picture, that word picture, and actually jot it down and make a right triangle out of it. That's the key. Right triangles. And then you just have to find one of the angles. Here's a common mistake. Common mistake is that people call this angle right here the angle of depression, because it's inside the triangle, but it's not. Remember, the angle of depression is from where? From the horizontal down to the line of sight. The angle of elevation is where? From the horizontal to the line of sight. Those two angles are exactly the same. And why is this angle equal to this angle? I don't think we even said it, but hopefully you already know. We've done a ton of this kind of stuff. Parallel lines cut by transversal, what are they? Yep, they're alternate interior angles. And so alternate interior angles are equal when you have parallel lines cut by transversal. So if that's 10 degrees, that's 10 degrees. We could have always found this one right here if we wanted to. If we knew this was 10 degrees, we know we have a right angle right here. So if this was 10, this would be 80. So if this is 80, look at the right triangle now. Remember, these two are complements of each other, so if this is 80, this has to be 10, because 80 plus 10 is 90, plus this 90 is 180. All right, so it all kind of fits together. I just like to look at it like this. If you start at the top, this is the angle of depression. I know my angle of elevation is going to be the same exact thing. All right, enough talk. Let's do an example. Okay, here's the example I was talking about. It's in the book. It's example 1. It's page 574. Let's just jot that down. Page 574, and it's example 1. Here's the picture. I didn't write out all the words and stuff, but let's just read it real quick. It says this girl Leah is meeting Fred's in a castle in the center of an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. Alright, so here she is. I know it's kind of hard to see here, but if you look in your book, it's a little more clear because this is a scan. It's not the greatest, but anyway, this is her right here. And she's standing on the ground, and she's looking at the top of the castle, which is right here. I'll just put a little point right there. Alright, so this is where she's looking. Now, she's standing on the ground, alright, but she's looking right here. Here's where her line of sight starts. Her line of sight, make it a little bit bigger, is about right there. So she's looking up here at an angle of elevation of 38 degrees. Alright, so I hope you can see that. From there to there is 38 degrees. And she's looking at the top of the castle. It says from the park's brochure, she knows that the castle is 190 feet tall. That means from the ground all the way up is 190 feet. And let's see. It says if Leah is 5.5 feet tall, See, remember, she's standing on the ground. She's 5.5 feet tall. So from the ground to her line of sight is 5.5 feet. Now, some people are saying, I know, well, the top of her head is 5.5 feet. Her eye isn't necessarily 5.5 feet, but we're saying from the ground to her line of sight is 5.5 feet. All right. It says, how far is she from the castle? And then it says to the nearest foot, which means you just round. So how far is she from the castle? Well, how do we measure the distance from her to the castle? Is it measured from A to B? No, that wouldn't be the distance from her to the castle. It would be from here, all right, because this is the top of the castle, so we're talking about the castle being right here. So it's from A to C. So we're basically trying to find AC. Let's redraw this, okay? Tell you what, let's draw the ground. Let's do the ground in a nice green for green grass. All right, so we'll say that's the ground right there. Maybe it looks green, maybe it doesn't. It is green. But I'll tell you what, let's shorten that up just a little bit. We don't have to make it so long. There we go. All right, so let's say that's the ground. And the castle, I'm not going to get real fancy on this. I'll just draw this in a nice gray for a gray castle. And the castle, let's say, goes up to here. All right, so far we've got the ground, we've got the castle, and how tall is the castle? It's 190 feet. All right, from where to where? From here to the ground is 190 feet. That's very important. Now it says she is standing up. So, I don't know. She's a girl. We'll make her pink, okay? So again, I'm not going to try to draw her or anything else. Oh, I don't know. Might as well. So that's just, now look, this is all I can do. I can do a stick figure, barely. That's not too bad. That looks pretty decent. So anyway, what's it say? She's 5.5 feet tall. So from here to here is 5.5 feet. I'll just put a little line here. Okay, that's a little ugly, but you get it. From the top to the bottom is 5.5 feet. And what is she doing? She's looking at the top of the castle. So let's do this in, I don't know, let's make it bright, make it yellow. Okay, so she is looking, we'll say from the top of her head, all right, from here to the top of the castle. And it says that the angle of elevation, so again, what did we talk about? We talked about the angle of elevation being, let's do this. Let's copy and paste this ground. The angle of elevation is from the horizontal to her line of sight. So watch what I'm going to do. You see that? I brought it up, still horizontal with this. So it's from the horizontal. It's not necessarily from the ground up to here. It's from the horizontal where she's looking to the line of sight. So this right here is the angle of elevation. And they tell us the angle of elevation is 38 degrees. So that's 38 degrees. And the question is, how far is she from the castle? Now look at this. Now this is important, that 5.5 feet thing right there. Let's just grab this color. All right. What we're going to do, this, I'm looking at this triangle right here. This right triangle. Okay, if you want to label it, that's A, B, and C, just like they do in the picture. So what I have to do is I'm not looking at from here all the way to here is 190. I've got to look from B to C and find out that length right there. Well, if she's 5.5 feet, so that means this little bit right here is 5.5. The whole thing from here, from B all the way to the ground is 190. How do I find the difference between the two? Well, it's exactly what we do. We find the difference, which is subtraction. So 190 minus 5.5 is what? 184.5, I believe. So that's 184.5 feet. That's from the top, from B to C, is what we're using here. So we're looking at this right triangle. And what are we trying to do? We're trying to find AC. We're trying to find out what AC is equal to. So let's go to green again, just so it stays consistent, but let's go to a different green. So what are we trying to do? We're trying to find what AC is equal to. Well, we've got a right triangle. I know one side and I know an angle. Really, that's all I need to know. And then I'm trying to find AC. Let's just call AC, let's not use D, I don't know, let's just let's just use X. Is that all right? So from A to C, we'll just use X. We'll just use one letter. Just makes it a little bit easier instead of calling it AC. So that's what we're trying to do. We're trying to find the length of this bottom right here. So here's the angle that we're working with. Look at the two sides. One they give you, one you're trying to find. The one they give you is BC. That's opposite this angle. The one we're trying to find is X, which is adjacent to this angle. So what do I have? I've got opposite and I have adjacent. If you want, you could just write it right here. That's opposite and this is adjacent. Which trig function uses opposite and adjacent? Well, that would be the tangent. So we're going to come over here and use the tangent. The tangent of the angle that we've been dealing with. So it's the tangent of 38 degrees is equal to the opposite over the adjacent. Okay, this will be a common mistake. A lot of people might put 190 here. I mean, you're looking at this thing and you're thinking, oh, that's 190. Well, it's not. 190 is from the top all the way to the bottom. We're only going to C, which is 184.5. So that's a very important part of this. So the opposite over the adjacent. Opposite is 184.5 over the adjacent, which we decided to call X. You could have called it AC if you wanted to. Okay, let's take a look at the math here. The math, X is on the bottom, I need it on the top. After you do these a while, you should get used to it. So I'm just going to assume that you know how to do this because we've talked about it before. You can look at it in one of the other lessons that I taught. So I'm going to put the X on the top and this tangent of 38 on the bottom. Basically just switching places with these two. Okay, and that works fine algebraically. So what's X equal to then? It's 184.5 divided by the tangent of 38. Alright, let's plug this into a calculator and see what we get, and we'll be finished. Alright, just happen to have a calculator right here, and let's put the numbers in. So it's 184.5, okay, divided by the tangent of 38. So I hit tangent 38. Close the parentheses, hit enter, and there it is, 236 point, let's just say 1. So we come back over here, and that would be 236. Now it says, actually it says round it to the nearest foot, so we're not even going to put the 0.1 because the 0.1 doesn't round up. We'll just keep it, don't know why that N is there. Anyway, we'll just keep it 236. So 236 feet, because it does say round it to the nearest foot. That's it. So what did we just find? We just found that length right here, the adjacent length. So how far is she from the bottom of the highest point of that castle? She's 236 feet. So 236 feet. That's all there is to it. It's really not that difficult. All these things are just right triangles. And look, they pretty much drew it out for you, so it made it really easy. But later on, what they're going to do is they're just going to give it to you in words, and you have to kind of figure out what's going on. You don't have to be real fancy. All I did was just draw straight lines to represent these things, except for my fancy little girl right there. Okay, but you get the idea. You can just draw straight lines. Make sure you have a right triangle, and you should be good to go. I think there's one more example that we want to do, so let's try that. All right, here's another example. It's all drawn out for you, nice and pretty. So let's read it. What does it say? Search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. So here we go. They're lifting somebody up and they see somebody else down here and they give you some details. It says if the angle of depression to this other person is 42 degrees. This is a key. See the dotted line right here? That's the angle of depression from the horizontal down to the line of sight. So it's not this angle inside of here. This is a common mistake people make. I just want to point it out to you. So it's from the horizontal down to the line of sight when they say the angle of depression. So if they didn't draw this picture for you, which sometimes they won't, not every single one of these problems the picture is drawn for you. So if they say angle of depression, it's from the horizontal. So if the person right here is looking, the rescuer is right here looking down at this person that needs to be rescued, you take from the horizontal down to the line of sight. Can't see that at all. Let's try red and make it a little bit bigger. Okay, so so here is your angle of depression right there. Now remember what we said about the angle of depression. Now they helped you out. They put it in here, okay? But again, you're going to have to figure this out on your own eventually. If the angle of depression is 42 degrees, then the angle of elevation which is right here. See, from the person's point of view, here's the horizontal, the angle of elevation goes up. So the angle of elevation is the same thing as the angle of depression. And it says that the helicopter is 18 feet above the water. So when they say it's 18 feet above the water, that means perpendicular. Remember we talked about the distance between a point and a line? It's always the perpendicular distance. So all that stuff's coming back to us. So there you go. You got a nice right triangle. You've got an angle inside here, and you've got one of the sides, and you're trying to find, it says, what is the horizontal distance from the rescuers to this person? The horizontal distance. So that means if I drop this straight down, what's the horizontal distance from where the rescuer will be dropped down and be able to swim over to this person that needs to be rescued? So we want to find what x is equal to. That's what we're looking for. Alright, well that shouldn't be too hard because I've got a side that they tell me. Okay, it's a right triangle, by the way, okay, because you got horizontal and you got vertical. So you've got one distance, you're trying to find another distance, and you have an angle. So if you have an angle in one side, you can always find the other side. You can find either this one or this one, but we're just trying to find what x is. Alright, so let's do the math. First of all, let's see what trig function we're going to use. We're going to use this angle right here, 42 degrees. What is this 18 to the 42 degrees? Well, it's opposite. What is this x? It's adjacent. So which trig function are we going to use? Opposite and adjacent. Well, we just used it, actually. So we would use the tangent. Let's do it over here. So the tangent of 42 degrees is equal to the opposite over the adjacent. That's 18 over x. Let's do our math. We've done this a couple times already. X is going to go up here. Tan 42 is going to go on the bottom. So x equals 18 divided by the tangent of 42 degrees. Right? And then we chuck that into a calculator. Alright, let's put this into a calculator. 18 divided by the tangent right here of 42, and enter 19.9. That rounds up to 20, so we will say that x, here we go, we say that x is equal to around 20, what? 20 feet. So let's slide this over a little bit. So that distance right there is 20 feet. So the rescuer is going to be dropped straight down and is going to have to swim over, I guess, or whatever, to get the person that needs to be rescued 20 feet over. Alright? So that's all there is to that. That's not so bad. Alright, check this one out. This one's a little bit more complicated than what we did before. Okay, you probably won't see a whole lot of these, but I thought I'd go over it. If you're running out of time in class, that's fine. You can skip it. You can just watch it on YouTube tonight. But I thought I'd go over it anyway because it's a good one to do. It's a little bit curved right here because the book, it was right in the middle of the book, and it's a little bit bowed right here. But we'll draw it out without the picture here in a second. So what's going on here? Well, you got this person right here trying to find out how tall the tree is. Now this person, it would be pretty difficult to jump up to the top of the tree, take a ruler or a tape measure or something like that, and then drop it all the way straight down. So that'd be kind of hard. So she decided, she's a smart lady, so she decided, well, I'm going to get, you know, a certain distance away from the tree, and then when I look up, I'm looking up at 70 degrees. You know, like when people are saying, wow, how in the world does she know it's 70 degrees? Well, they do make devices, and maybe she's got one. Who knows? I have no idea. But anyway, she's standing right here at point C, and she's looking straight up to the top of the tree, and she notices that it's 70 degrees, all right, from being this distance away. She doesn't know how far away she is. I don't know why. I guess if she measured this, you'd figure she could measure this one. But for the sake of the problem, she doesn't know how far away she is from the tree. But she does know this. From here, she backs up 10 meters, all right? Somehow she knew it was 10 meters, and then she looks up at the top of the tree. Look at the angle that's created. The closer you get to the tree, the steeper that line of sight is. The further back you go, okay, the less steep that line of sight is, as you can see right there. All right, so she measured it to be 26 degrees. She knows how tall she is. All right, she's 1.7 meters, and you probably think, well, I don't know what I am in meters. Well, probably everybody else in the world knows what they are in meters except for us, because everybody uses the metric system. But anyway, she knows she's 1.7 meters tall. All right, and with that information, that's actually enough information. All she had to do was figure out how far back, okay, from her initial position she is, and a couple angles, and how tall she is. All right, that way she could actually find the whole height of the tree. All right, that's pretty cool because those are easy measurements to do. Yeah, the degrees maybe aren't so easy unless you have a little device to use for it, but it's a lot easier than climbing up to the top of the tree and throwing down a tape measure and figuring out how tall the tree is. Okay, so that's what she wants to do, is how tall the tree is, from not from A, B, but from A all the way to here. Well, let's think about this for a second. If I could just find from A to B, which they used as X, from A to B, all I got to do is just add another 1.7 meters, and then I've got this whole thing. So really, X is what we're really trying to find, right? So that's pretty important. But we also have to find what Y is. Well, how in the world do we start with that? Well, we got two triangles. We actually have three triangles, but we have two right triangles. Let's just deal with the right triangles. And let's draw this out just with straight lines instead of all this picture and tree and all that kind of stuff. So we'll try to draw it fairly neat. We'll try to be as neat as we can. So there it is from D to B, and then if you go straight up, that's up to A. We'll try to keep it about the same. And watch, this one goes to C, and then this one goes to D, which is right there. So that looks a little bit better without all the junk around it. Alright, and this is 26 degrees right there. This is 70 degrees. This is 90, so it's a right angle. We'll call this X. We'll call this little distance Y, and we'll call this distance right here 10. Now remember, I'm not even going to put the 1.7 in here because once we solve for X, all you got to do is just add a 1.7 and you're done. So that shouldn't be that big of a deal. So let's take a look without all that stuff around it, how we're going to solve for X and how we're going to solve for Y. Well, let's take a look at this little triangle right here. Problem is, I only know the angle, right? Remember before I said if we know the angle in one of the sides, we should be able to find the other sides. The problem is I don't know either one of those sides. But what I'm going to do is I'm just going to, I don't know, do what I can do here. Watch, this is 70 degrees. They label this as X and this is Y, so this is opposite and this is adjacent. So what's opposite and adjacent? That would be tangent. So let's just write it down, see what we can do with this. So the tangent of 70 is equal to the opposite over the adjacent, which is X over Y. Now I can't really solve for X because I don't know what Y is, and I can't really solve for Y because I don't know what X is, but let's solve for one of them in terms of the other. This is what I mean. Let's just get X by itself. We could do it either way. We could get Y by itself or X. It's a little easier to get X by itself because all I have to do is multiply both sides by Y. So let's write it out. X equals, now watch, take this Y and put it over here. So multiply both sides by Y and I get this. So X is equal to Y times the tangent of 70 degrees. That really doesn't tell me anything because I don't know what Y is equal to. But what I'm going to do, I'm going to put this in a little box. We're going to hang on to it for safekeeping. Alright, we'll get back to it in a little bit. What I want to do now is I want to figure out something about the big right triangle. Take a look at the big right triangle right here. Because I have an angle. Right? The reason I'm using the little triangle and the big triangle is because I've got an angle for this one and I've got an angle for this one. So let's think of some trig. Use this angle right here, 26 degrees. What do I know? Well, here's that same side that I don't know. Alright? So it's X. That's the opposite side. What about this side right here? That would be the adjacent side. But what is it? Is it just 10? No, because 10 only goes to here. So what's the length of this whole entire side from here to here? It's not 10y. A lot of people say it's 10y. It's not 10 times y. Right? If I knew what this was, let's just pretend it was like 3. How would I find that whole distance? I would go 10 what? Plus 3, not 10 times 3, right? So that would be 13. Well, I don't know that that's 3. I just made that up off the top of my head. How would I find that whole distance? I would go 10 plus y. That's that whole length right here. So let's do this again. I've got opposite, which is X, and I've got adjacent, which is 10 plus y. So let's do that. So I'm going to do some different colors so I know what we're doing here. So the tangent of 26 degrees is equal to opposite over adjacent again. Well, the opposite is still X, but this time what's the adjacent? The adjacent is 10 plus y. or y plus 10. I'm just going to write a y plus 10 if you don't mind. Now look what we can do here. Up here we solve for x. Let's do the same thing here. Let's solve for x right here. So how would I do that? Basically the same thing that I did here. I would multiply both sides by y plus 10. Y plus 10. Okay? So look what we get. We get x equals, tell you what, let's write it like this. Let's put the tangent first, if you don't mind. The tangent of 26 degrees. Now, the tangent of 26 degrees is just a number. It's a number that I can put into my calculator and figure out what it is. And it's being multiplied by this y plus 10. Alright? So, there you go. I've got two things. They're both equal to x. This is equal to x, and this is equal to x. Well, check this out. If they're both equal to x, then they're both equal to each other. It's just simple substitution. And hopefully you learn a little bit of that in Algebra 1. You'll do a ton of that kind of stuff in Algebra 2 next year. This is really a good precursor to Algebra 2 with the substitution and stuff. So what we're going to do is this. Let me scooch this up a little bit. We don't really need the triangle right now. We'll come back to it. Look what we have. This is equal to x, this is equal to x, so this and this must be equal to each other. So let's actually set them equal to each other. I'm going to go y equals, I'm sorry, not y equals, what am I doing? They're equal to each other. It's just y times the tangent of 70 equals, remember, these are equal to each other because they're both equal to x, they're equal to each other. So y tangent of 70 equals this thing right here, the tangent of 26 times y plus 10. And guess what I'm going to do? I'm going to do a little bit of algebra, and I'm going to solve for y. That's what I want to get. Now, hopefully I don't lose you too much on this algebra. This should be Algebra 1 material, but again, you haven't had Algebra 1 in a long time. We haven't done much of this in geometry, but hopefully you'll follow along. So look, there's nothing I can do here. So I just keep that. That's a 70. What I could do here, remember, this tangent of 26 is just a number. Well, what would I do if it's being multiplied by parentheses like this? I would distribute it through. So let's do this. Tangent of 26 times y. I'm going to write it like this. Y times the tangent of 26. It's the same thing, but we usually put the number out in front of the tangent. Plus the tangent of 26 times 10. Now again, the same thing. I put the 10 out in front, and I put the tangent of 26. Alright? So far, so good. Now look, I got y's all over the place. I got a y here, and I got a y here. What I want to do is I want to get a y on the same side. So how am I going to do that? Well, this is just acting as one number. So it's being added, so I'm going to subtract it from both sides. Hopefully you follow along. Alright, so y tangent of 70 stays here. How do I get rid of this thing right there? Well, I subtract it from both sides. So, oops, almost put tangent. It's y tangent of 26 equals, I didn't do anything to that, so I'm just going to keep it 10 tangent of 26. Now look, 10 tangent of 26 is just going to be some regular old number I'm going to put in a calculator. Don't put it in right now though. Wait till the very, very end before we use a calculator. Now look at this. I've got a y here and I've got a y here. Well, I've got a y in common with both of these. If you remember from algebra, we can factor out this common y. So what I'm going to do is factor out a y. If I factor out a y, because it's the greatest common factor, it's in common with both of these terms right here. If I take it out, factor it out, what do I have left? I'm basically taking this and dividing it by y. So if I take this whole thing divided by y, what am I left with? I'm left with the tangent of 70 minus, factor out a y from this. That goes right here. What am I left? I'm taking this basically and dividing it by y. What do I get? Tangent of 26. Okay, equals 10 tangent of 26. We're actually getting there, I promise. Now look at this. Now, instead of having two y's, look, over here I had a y on both sides of the equal sign, which I didn't like. But now at least I moved this over. Now, but I still had two y's here. Didn't like that, so what did I do? Greatest common factor. Okay, pulled out a y out of this. And now I just have one y. So that works out real nice. But it's being multiplied by all this mess right here. Well, how do I get rid of something that's being multiplied? Well, I divide. Right? So I'm dividing by this stuff right here. And I'm not going to show the division because I know it's going to cancel out. Watch. So all that will cancel out when I divide it. but I have to divide it by the other side as well. So I'm dividing it by the tangent of 70 minus the tangent of 26. That's what y is equal to. Now, all this we just put into a calculator and we come up to an answer. For y, okay, we still haven't found x yet. All we found is y. Bear with me, okay? I told you this was a little more complicated than the other ones, but this is good for you, okay? This is good that you see that not all math problems are solved in 1 or 2 steps. Okay, watch very carefully how we put this into the calculator. This is pretty important stuff. What I'm going to do right here, watch. It's going to be 10 tangent of 26 divided by this whole thing. It's very important that you do this. Okay, I put a parentheses here and a parentheses here. So watch what we're going to do. Whoops, don't know I got the V. Okay, here we go. 10 tangent of 26. I'm going to close the parentheses just to be nice and neat about this. Divided by, now watch what I'm going to do. See this parentheses right here? I'm going to put a left parentheses. And then I'm going to hit tangent of 70. So it's going to be tangent of 70, close that parentheses. Okay, then I got a minus, and then a tangent of 26. So tangent of 26, close that parentheses. Now watch what I do. See this parentheses right here? That's really not that one. I'm going to put one more parentheses. Alright, I just feel better about that. See, this first parentheses is this one. This very last parentheses is this one. Okay, the other ones are just right here and here and here and here. Hopefully you understand that. Okay, hit enter, and there it is, 2.158. We'll just round it. I think in the book they rounded it 2 places, so let's just go ahead and do that. 2.16. So 2.16. Alright, so that's what y is equal to. Let's figure out what x is now. Alright, let's we know what y is. Tell you what, let's circle that. We know what y is equal to. We got to find out what x is now. Well, we actually have 2 different values for x. We could use either one of these. Well, which one's the easiest one? Well, the one that looks the easiest. Probably this one right here. So let's use that. With my cool little program here, I can actually copy it. I'll come down here and let's kind of move that over and kind of move it over here. Alright, just so I see everything. Alright, so now there's what y is equal to. Now what I can do is just plug it in for this and solve for x. So what's x equal to? X equals y, just found it, 2.16, okay, times the tangent of 70 degrees. Alright, so x is equal to that. So let's plug that into our calculator. Okay, 2.16, oops, let's clear that again. 2.16, 2.16, there we go. Tangent of 70. And let's see what we get there, 5.9. And let's see how much they rounded. Yep, they just rounded 5.9 as well. So we'll just keep it 5.9. Alright, so that's what x is equal to. So there's y and there's x. Alright, but we're not finished, I don't think, are we? We have to find how tall the tree is. Remember that? Okay, I moved all the answers over here so we could see next to the picture. So what are we trying to find? We're trying to find out how tall the tree is. Well, what we just found, we had to find y first. Okay, they didn't ask you to find y, but you had to find it to be able to find what x was equal to. Alright, to put it back into that substitution. So we know how tall it is from A to B, but we want to find the whole tree, the height of the whole tree, from A all the way down to the bottom. Well, the bottom was what? 1.7. So, like from here, can't see that very well. Let's try a different color. Let's make it a little thicker. Okay, watch. From here to here is how tall? It's 1.7. So what do you have to do with this x? This x was 5.9, so it's just a matter of adding those two things together. So the height of the tree, we'll call it h, is equal to 5.9 plus 1.7. And so what's that going to be? 6. That's going to be 7.6. So the height of the tree is 7.6 meters. And let me see what else. that they want. We'll put the meters right there. That's the height. That's all they do. They show you how to check it. That's what I was looking at, but we don't need to worry about that. That's it. That's how tall the tree is. All right, well, I hope that wasn't too crazy. I know we went way long on this, longer than I've ever gone, but hopefully you stuck it out and you enjoyed that problem. That was kind of fun. I enjoyed it. All right, well, you guys have a good weekend, and I'll see you on Monday.